Okay, today we're going to look at the antiderivatives of inverse circular functions. Right, in 4.7 we learned how to derive inverse sine, inverse cos and inverse tan, and obviously going forwards we ended up with 1 over square root a squared minus x squared, negative 1 over square root a squared minus x squared, and then when we derived tan we got a constant over a constant squared plus x squared. Now we're looking at going backwards. Therefore, if we were presented with 1 over square root a squared minus x squared, this obviously must have come from inverse sine x on a. Negative value came from cos, and constant over constant plus x squared. Once you see a fraction with number x squared, you start thinking about tan as a possible option. So let's have a look at one. Let's say we had 7 over the square root of 16 minus x squared dx. Okay, so first thing we would do, we take out 7, which is a constant, and we're left with 1 over 16 minus x squared dx. Now that looks good now. You've got 7. This 1 over 16 minus x squared looks exactly like this, which means must have come from inverse sine x over, I've got 16 as my a squared, therefore 4 is my value of a. Let's say we have 10 over 25 plus x squared dx. Looking at this, okay, there's no square roots, it's a fraction, there's x squared on the bottom line. I start thinking, is it a tan function? So what I do is I always take the constant out. I write the denominator down, 25 plus x squared, and then what I look for is what do I need to put on top to make it look like this formula here. Okay, you want this is what the tan function looks like, so there's a missing value here. I would put in 5, and because you've put 5 in here, obviously to keep the thing balanced the same, you need to divide by 5 out on the outside. So we have 10 over 5, 2. This is now simply an inverse tan function, x over 5 plus c. Last possible simple case, negative 3 over square root 25 minus x squared. Okay, two options here. You could take negative 3 out and therefore make it look like this one here. Or we take out 3 and we leave negative 1 on the inside, square root 25 minus x squared dx. And so that means it's 3. And because it's negative, we go cos x on 5 plus c. Let's look at more complex functions now. What happens if we had 7 over square root 25 minus 9x squared dx? Okay. First thing we do is take out the 7 because we don't like that, and we take out, so we're left with 1 over 25 minus 9x squared dx. However, we're normally interested, or our rule is a squared minus x squared. So what I'm going to do here is take out the 9, not completely yet, and that leaves me 25 over 9 minus x squared dx. Right. Reason is I want to get myself just x squared here. So 7. This 9 here is under a square root. Square root it, you get 3, take it out the front. Then you're left with 1 over square root 25 over 9 minus x squared dx, and of course that looks like sine. So inverse sine x over a. A is the square root of this value here, so a is 5 over 3. So after all that, 7 on 3, inverse sine 3x on 5 plus c. Now, you know by now, I like my general rules. Should be able to generalise this and do it in one step. So let's say we're looking in the form a over b squared minus d squared x squared. Okay, so that corresponds to that 7, 25, 9. So it looks like that. Following the pattern, you know that this is going to be inverse sine. Having a look at the angle is 3 over 5 in our case, compared to what we started with, which was 25 and 9. You're always going to be square rooting these numbers. So according to our formula, it'll be D on B. You'll have a constant out the back. You had A initially, so there's A, see, 7 matches 7. And this time we had a 3 here. And the 3 came from square rooting the 9 back here. Alright, so the 9 turned into the 3. Therefore, take this out and you get D at the front.